As described in the business plan, the white blood cells activated in an autoimmune response are attracted to the inside wall of the blood vessels in what is referred to as soft adhesion process called rolling. Here you can see the white blood cells slowing down and beginning to roll along the inside wall of the blood vessels. This is in preparation for a more firm adhesion process called sticking, and in these segments you will see the white blood cells, which have been marked with a phosphorescent dye, begin to slow to a stop as they stick to the inside walls of these blood vessels. You'll notice in the upper vessels they have come to a complete stop. In the lower vessels, the white blood cells continue to flow at full velocity because the chemical agents that activate the adhesion process are very localized and only affect the blood vessels in the area where the chemicals are released, which in this case are in the upper portions of this video. You'll see that the white blood cells are stopping and beginning to bind firmly to the inside wall of the blood vessels. After binding, the white blood cells pass through the wall of the blood vessel in a process called extravasation. You'll see here in this video the white blood cells passing out of the blood vessel and into the tissue. As we continue to watch, we see the white blood cell move further and further away from the vessel, where eventually it would release its toxic proteins, causing the severe inflammation and swelling that marks many autoimmune diseases. The blue arrow is pointing at the eosinophil, in this case, that has passed far outside the blood vessel, deep into the surrounding tissue. Here we see it 12 minutes later, continuing its migration for a target. The target that it is seeking is the center point of the chemical release that activated the white blood cells in the first place. Here we are looking at it 20 minutes later. This is further evidence of the late phase response that is referred to in the business plan. The last segment here is the actual injection of our drug into a specimen. You'll see the white blood cells binding to the inside wall of the blood vessels prior to injection of our drug. At this point, the drug is injected, and the monoclonal antibody, as we call it, VLA-4 Antagonist, will actually dislodge the white blood cells from their binding sites. This occurs because the drug has a higher affinity for the binding sites and dislodges the more weakly attached eosinophils. As we view the demonstration minutes later, we see that the blood flow has returned to full velocity. The white blood cells have dislodged and have moved off, and flow out of the area into circulation. This demonstrates the effectiveness and promise of our cell adhesion antagonist.